This video introduces a reconfigurable building block for thermoelectric generator energy harvesting under spatial temperature variations submitted in ISLPED design contest. Every vehicle with an internal combustion engine has a radiator. Inlet temperature of the coolant, which is hot, is at around 100 degrees Celsius. Coolant flow rate varies with the engine operation. Energy harvesting radiator using TEGs is introduced before, but our focus is on how to maximize the amount of energy harvesting by a system solution. Each TEG module shows a significant efficiency degradation even if the power converter has the maximum power point tracking. For TEG module array reconfiguration, each TEG module is integrated with 3 solid-state switches, a top parallel switch, a bottom parallel switch, and a series switch. The picture describes about the parallel and series system configurations of TEG module arrays with the switches. This slide explains about the vehicle radiator thermal energy harvesting platform. We implement on the emulation system of the radiator with the proposed reconfigurable TEG module array as shown in the figure. From the block diagram, we assumed that the vehicle powertrain cooling system indicated as red coolant and ambient air with the fans is cooling system with the blue coolant. In the figure, the emulator consists of hot and cold coolant circulation systems with the reservoirs and pumps with the pulse width modulation control, and a heater with on and off control, an air-cooled radiator, and a reconfigurable TEG array. For the vehicle radiator thermal energy harvesting platform, we use an active load with the ISLPED based perturb and observe control program. This slide shows a scalable and networked reconfigurable TEG module building blocks. It has ability to display current switching state and also support the dynamic reconfiguration. The assembled reconfigurable TEG building block consists of a control module, PIC 8 MHz microcontroller, isolated MOSFET driver, switch MOSFETs, liquid heatsink block for heating and TEG module, and liquid heatsink block for cooling. A reconfigurable TEG building block consists of several components such as microcontroller, sensors, interconnections, and isolated power MOSFET drivers and switches. It has the specification of 40mm by 40mm board size, 38.4 kilobytes per second UART of communication, and 3.3 operation voltage. It has 2 ways of reconfiguration, in parallel with the 2 switches and in series with the 1 switch. This slide describes about the TEG building block reconfiguration procedure. This algorithm operates on the TEG temperature variation for the building block reconfiguration. Radiator simulation in the building block reconfiguration algorithm will be presented as an oral presentation in ISLPED 2017. We made a MATLAB-based software application. This developed software has 3 operation modes: automatic reconfiguration, fixed array, and the stop running. Automatic reconfiguration runs reconfiguration based on the current temperature and the flow rate. Fixed array is a setting 4x6 rectangular array, and stop running safely turns off the work. In the display, they display information including inlet and outlet temperature of hot side coolant and the current configuration. We also provided the serial communication to platform controller and the TEG building block controller.